Welcome to eMath. So today we are looking at applications of linear functions or lines. Applications of lines. How lines are applicable to our real life problems, right? So these lines are mostly applicable to demand and supply. Finding demand and supply equations that are linearly, where demand and supply are linearly related, where quantity and price are linearly related. So we call that a typical demand and supply graph. The demand graph looks like that, where this is the price P on the y-axis, the vertical axis, and the quantity on the horizontal axis, right? The graph looks something like that. And for supply, it looks something like this, where Q and P are also having on the horizontal and vertical axis respectively. Something like that. And like that, right? So that's for demand and that's for supply, basically. So note that a point XY on the demand and supply axis will be QP, basically. All right, QP on the demand and supply curve will be QP. Okay, let's look at the examples. Look at quiz problems 3.2. So this was section 3.2, applications of lines to demand and supply equations. So question 15 says that suppose consumers will demand 60 units of a product when the price is 15.30, and when the price is 19.30, they will demand 35 units. Find the demand equation, assuming that it is linear. Then part B says find the price per unit when 40 units are demanded. All right? So define the demand equation, assuming that it's linear. So in this case, we are told that the quantity demanded will be 60 when the price is 15.30. So the point Q1, P1 will be 60, 15.30, and the quantity demanded will rise to 35 when the price drop goes to 19.30. All right, so Q2, P2 will be 35, 19.30, like that. Okay, and we are asked to find the demand equation if the quantity and price are linearly related, or if the demand equation is a linear function. Right, so this is just simple. 2 points on a line. We want to find the equation of a line given 2 points on that line. So first things first, we find the slope of our line, which will be P2 minus P1 over Q2 minus Q1. Remember that QP is representing X and Y, like the case in our normal Cartesian plane. This case now is a demand and supply graph, all right? So, which would then be 19.30 minus 15.30 divided by 35 minus 60. Okay, so which is 19.30 minus 15.30 should be 19 minus 15 should be 4. 4 divided by 35 minus 60. So 30 minus 60 is negative 30. So 35 should be negative, negative 35 minus 60 should be negative 25 then, right? So minus 4 over 25 is then our slope. Then we use our slope point form to find the equation of the straight line or the linear demand function. So our function is then going to be P minus P1 is equal to MQ minus Q1. Same story, all right? Just that Q and P are now replacing X and Y, all right? The same thing. Q and P are now replacing X and Y because we are talking about quantity demanded versus price. Okay, so P minus P1 will then be P minus 15.30 is equal to M, negative 4 over 25, Q minus 60. Okay, rearrange and write your equation in standard form, isolating P minus 4 over 25 Q minus 4 over 25 times minus 60. All right, this times this is this, right? And remember that we need to move this guy to the side, so we are adding 15.30. Okay, then you can work out that using your calculator and get your equation in standard form. Okay, let's take another example. Questions 17. 17 says that this one is a supply case. Suppose a manufacturer or a refrigerator manufacturer will produce 3,000 units when the price is $9.40, right? 3,000 units when the price is 940, that's 1 point, all right? And then 2,200 units when the price is 2,200 units when the price is 740. Fine. Okay, I think we didn't finish with the previous question, all right? We didn't finish the previous question where we were asked to find the price per unit when 40 units are demanded. So all you need to do here is then to substitute Q equals 40 in here, all right? Then calculate and get P. Just substitute 40 in place of Q. When Q is 40, what is P? That's just the question. So you substitute Q equals 40 in here, and then add up everything and get the price when 40 units are demanded. Okay, so the second one then gives us these 2 points. Same story. Okay, this is my Q1 P1 and my Q2 P2. All right. First things first, I find my slope, which is given by P2 minus P1 over Q2 minus Q1, which is 740 minus 940 over 2,200 minus 3,000, which is negative 200 over 2,000 minus 3,000 should be negative 1,200, right? Okay, we then divide this, we get 2 over 12, which is 1 over 6 as our slope, right? Then we use our slope and one of these points in the slope point form to find the equation. So my equation will be P minus P1 equals MQ minus Q1, which is P minus 940 equals 1 over 6 Q minus 3000. Then we rearrange and write our thing in standard form. P minus 940 equals 1 over 6Q minus 3000 over 6, 500. So that P is equals to 1 over 6Q minus 500 plus 940, right? So that P is 1 over 6Q, so it's minus 5, so 940 minus 500 should be 440 plus 440, right? And that's it's 940 minus 500 and 440. Okay, and that's our linear supply equation there. Linear supply equation for that question. Okay, let's look at another one. Number 19 talks about cost, right? Talks about cost. 19 says, suppose the cost to produce 10 units of a product is $40. Okay, cost to produce 10 units, Q is 10, P price will be 40, that's 1 point, right? And the cost to produce 20 units is 70. 20 units cost 70 to produce, right? Find the equation relating C and Q if it is linear, and find the cost to produce 35 units. Okay, so the same story. We find our M first, being our Q1, P1, Q2, P2. M will be P2 minus P1 over Q2 minus Q1, which is 70 minus 20 minus 40 over 20 minus 10. So we get a 30 over 10, which is 3. Okay. Then our equation, P minus P1 equals M Q minus Q1. Same story, right? P minus P1 is 40 equals 3 Q minus 10. Rearrange. P is 3Q minus 30 plus 40, which is 3Q plus 10, right? And then the next question says that the next part of the question says that we should find the cost to produce 35 units. So we've just had our price to be 3Q plus 10, right? We've just had our P equals 3Q plus 10. So the cost to produce 35 units. So when Q equals 35, P will be 3 times 35 plus 10. Cost to produce 35 units, which is 3 times 35 should be 105, if I'm not mistaken. 105 plus 10, which is 115 rand. That's the cost to produce 35 units. Okay, and all the other problems there relating to demand and supply are basically just the same as these ones, all right? They are basically just the same as these ones. Okay, so while you solve, leave out the ones with the isocost. The isocost questions are not really relevant for us. Okay, So that's that for demand and supply, basically the applications of lines to demand and supply.